Ever wonder about the basic magic that literally powers our world? From our cars to massive power plants, it pretty much all boils down to one incredible trick: turning fire into motion. So let's dive in and really unpack the genius behind heat engines.
All right, here's our game plan. We're going to start with the big idea, what a heat engine even is. Then we'll see how they split into two main families. From there, we'll check out the raw power of steam, then jump into the controlled explosions happening inside internal combustion engines, and finally, we'll tie it all together with machines you definitely know.
So first things first, at its absolute core, a heat engine is all about unlocking the incredible power that's just sitting there, hidden inside thermal energy.
And that really is the fundamental challenge, isn't it? How do you take something as wild and, well, chaotic as heat and somehow tame it to do useful, predictable work for us, like turning a wheel?
The answer, of course, is a heat engine. The definition is super simple, but it's actually pretty profound. It's any machine that takes thermal energy, heat, and transforms it into mechanical output. And that's just a fancy way of saying movement.
Okay, now here is where it gets really cool. Almost every single heat engine you can possibly imagine falls into one of two main categories. And the difference between them? Well, it all comes down to one very simple question.
And that question is simply this: where does the burning happen? Is the fire inside the part of the engine that moves, or is it happening somewhere else completely? Seriously, the answer to that one question divides the entire world of engines. So, on one side, you've got external combustion. This is where the heat source is outside the main engine. Think of a big furnace heating up some water. And on the other side, you have internal combustion, where the fuel burns right there inside the engine itself. Outside versus inside. If you remember just one thing from this, make it that distinction.
All right, let's kick things off with external combustion. This is really where the whole story of industrial power begins, and it is all about harnessing the absolutely incredible power of steam.
Wow, just look at the sheer scale of this thing. This is a steam turbine, and it's basically the modern hero of external combustion. These enormous machines are the heart of most power plants all over the globe, whether they're running on coal, natural gas, or even nuclear energy. These are the giants that generate the electricity powering our lives right now. So, how do they actually work?
Well, at its heart, it's a device that grabs the thermal energy from superpressurized steam and cleverly converts it into rotary motion, which, in other words, means spinning.
And this breaks down the whole process beautifully. Okay, so step one, somewhere else entirely, a boiler is producing a massive amount of pressurized steam. Step two, that steam gets funneled down and expands into a crazy fast current. Step three, this jet of steam then blasts against all those little blades, or vanes, on a wheel. And finally, step four, that force pushes the wheel and the whole shaft it's connected to, making them rotate at unbelievable speeds.
Okay, so let's hop over to the other side of the family, internal combustion. This is where we take the fire from that separate boiler and we put it directly inside the machine itself.
In this category, it's home to two engines you are definitely familiar with: the gas turbine, which powers pretty much every jet you've been on, and the piston engine, which powers most of our cars and trucks.
So let's take a closer look at these two absolute icons of internal combustion: the continuously spinning turbine and the classic up and down motion of the piston engine.
First up, the gas turbine. If you have ever flown on a plane, you have been pushed through the sky by the incredible, raw power of these engines. This diagram shows you the whole journey. On the left, a huge amount of air gets sucked in. Then, in that middle section, it gets squeezed, mixed with fuel, and boom, ignited. Then, that super hot, expanding gas blasts out through the turbine on the right, which creates all that thrust and, get this, also powers the compressor at the front. It's this perfect, continuous, powerful cycle. It's really just a powerful three-step dance. 1. The compressor right at the front sucks in and squeezes the air. 2. In the combustion chamber, fuel gets sprayed in and ignites with that hot, compressed air. And 3. The resulting high-pressure gas just blasts through the turbine, spinning its blades and the main shaft to generate all that power.
Next up, we've got the engine that moves the world on the ground, the diesel engine. This is the absolute workhorse of our trucks, our trains, and our ships. So instead of using expanding gas to spin a turbine, a diesel engine uses that explosive force of combustion to literally shove a piston down inside a cylinder. You can see it happening right here. That powerful downward punch is what turns the crankshaft and ultimately what turns the wheels.
So what is it that makes a diesel engine so special, so efficient? Well, it really comes down to this number, 15:1. That's a pretty typical compression ratio. It means the air inside that cylinder is squeezed into a space that is 15 times smaller than its original volume. That incredible pressure is the whole key.
And here is the magic trick. That intense pressure heats the air up so much, we're talking hundreds and hundreds of degrees, that the very instant diesel fuel is injected, it ignites all on its own. There's no spark plug needed. It's called compression ignition, and that is the secret sauce to the diesel engine's amazing power and efficiency.
So let's just put this all together real quick. External combustion, it happens outside, like in a steam turbine where steam that was made somewhere else comes in to spin the blades. Internal combustion happens inside, like a gas turbine where burning gas spins the blades, or a diesel engine where that same burning gas pushes a piston instead.
And in the end, it all comes back to this one unifying principle. Doesn't matter if it's external or internal. The goal is always to create high-temperature, high-pressure gas. It's the expansion of that gas that directly applies force to a moving part to generate useful work. That's it. That is the entire secret of every heat engine.
When you think about it, from the very first steam engine to the modern jet engine, these incredible machines literally built the world we live in today. And that kind of leaves us with a final thought, right? What kind of engines, what new ways of turning energy into motion are going to power the world of tomorrow?